Hello everyone. We yesterday I have explained you all about collection and collections, list, array list, vectors, stack, linked list. I have given you some example also, and today we'll continue from there. We'll see how set works. Let's go. Let me open my Eclipse. This is what I have shown you yesterday. I will do one more example here. Rather taking array list, I'll show you for linked list. So for that, let me share my screen. I missed it to share the screen. So let me share the screen. My screen is visible to everyone now. Here it goes. I just copy paste this array list up from the top. I'll make it linked list. So one example of linked list to you all, how it is. That's all. Engineering student will be knowing what is a linked list. Linked list has a head node, and then all are child nodes. Head and child nodes. So the head node will refer to the first node that will be holding data and value, and accordingly, it will the first node will have data and reference to the second node. The second node will have data and reference to the third node. Like that, it will go till the end, and the last node will hold the reference of a null value that will not be pointing to anything else. In the case of circular linked list, it will again refer to the fast one. So there are so many concepts of data structure. We will not discuss data structure here. We are discussing about array list, you know, list type here, even by Java. So this is what called a linked list, right? So this is how you iterate here. See, this you can also get by using index, right? Here what I will do, I have added so many employees, and what I will do, I will just add one more here. You know, I will copy this value all at the end here, right? And this EMP I will make it 82 so that you will be able to see the difference in IDs. And then I will explain why I did that. We are printing only IDs, right? Oh, all came 82. All came 80. Oh, yeah, all will come 82 because this is what I did. I set it fine, but I've not created any new object, right? That same object I'm modifying. So that's why all came like that. So I have to create a new object because all of them are referring to same reference, same memory location, right? So I have to put this line also here. Hmm. Now say last one is coming as 82, right? So here for each you can use, and what else you can do? You can also do like this. Employee, what is that? List, right? Employee list dot get index is there, right? It is similar to array. Index is there. So see how many first index is line number 39 is first index, that is 0. Line number 40 is second index, that is 1. Line number 41 is third index, that is 2. And line number 48 is fourth index, that is 3. So I'll put here index 3, right? So here you will see 82 once more time. See, so by index also you can fetch it. So now let's go to linked list. To show you the difference, I made it. Right. Linked register. So linked list, see, I only change the variable, but accessing I am done the same way. See, so let me run it. Everything is same. You go vector, stack, everything is same. Stack concept will follow stack, push and pop, right? So that is how it. See, it worked also. Now for this, if I want to go on this way, this the same thing, the same way of accessing. Linked list, employee linked list, dot get. Yeah, I can access this also. No? That is all. But the internal implementations follow the linked list concept of implementation. See here, you see equals hash code index of is empty, last index, offer last. So many methods, remove. So many methods are there. You can try all of them to see to array. So many methods. You can convert one array list to a array and array to a array list. There are utilities methods. See, you have all things here, right? Peak first, peak last, poll first, poll last, pop, all the operations you can use and you can try to get the outcome out of it, right? You want me to show the vector? I can show you the vector also. Let's copy paste this thing. You know, before going to the other, let's go and do all of them so that it will be clear. Okay, what happened? Vector employee, right? Now let's make it vector. And that we keep it the other side also vector, right? So you see, I added into a vector and I am accessing it the same way. Let me put one SOP same vector. Vector. See, it is the same thing. Similarly, you can go for stack also. Let me copy this and show you the stack. Stack is the subclass of vector, right? See the same way. I will run it. But you see how it is displaying the output. 82, 82, 82 stack, right? This is how it is coming out. Let's go to the stack. So you see, as I said, it extends vector, right? And public stack the constructor, push and pop, pick. empty. Since it is extending vector, you know, you can, since it is extends vector, you will have the all the methods of list here. That is the reason when when we run it like this, it is iterating based on the index. So we should not use stack in such way, right? Stack is always for push and pop. So what you do, rather using for each loop, you use it int I equal to 0, right? Here I less than stack employee dot size, right? The number of size you have, I plus plus. Here what you do, here stack employee. You have to use that because we removed for each and the employee is out. Dot pop. This you should use, right? Oh, okay. That is fine. Size. Size is always like this. Array index out of क्या बोल दिया what it said, array index out of range 3, so 3 is not there, so that's why it is array index out of this. Fine. Salary employee stack pop मैंने कैसी I did pop what it is saying age 44 age 44 age 44. So technology innovation, this is how it came out, right? And why it is not storing the other array index out of range, maybe because of the IDs, right? The IDs are same. No, no, this I should commit it out this guy. 3 is not there. It is showing the error. Now let me run it again. See, the stack is printing, right? Now we have added here 1, 2, 3, 4 employee object. Right? We have added 4 employee object here. 4 employee object we have added, but we are able to see only 2. Right? Why? That is another question here. Fine. So here, add is not the right way to do. You have to write push. In stack it is push. In stack it will be push operation always. So that is if you are implementing stack, you have to follow the stack logic. It should be push and it should be pop. So let me run it now. See, it is coming out, right? So efficiently we're able to pop. But we're able to only pop the two employee object because we have inserted two, you know. So let me do something. Here, this one Satya, this one 82, I'll make double A, right? And let's see what it is doing. Does it take duplicate or not? See, it is only printing Satya, Satya, Satya. Why? The reason behind that, this employee equal to new employee, right? Whatever I'm setting here, everything is going into that. So let me do something like this. It is employee, and let me make it employee one. Make it employee one. EMP, EMPP, right? So here EMPP at the end, EMP, EMP, EMPP, only one, right? So everywhere we'll do that. EMP, 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 EMPP. We are concerned about stack. So we'll come to stack. We'll do like this. We'll see what is the output now. Here we are getting one Satya and one Satya, other Satya. Only two objects got pushed into this stack. Whereas we are trying to push so many things, right? So many objects. So always always you should use push and pop operation in case of this thing. So let me see one more thing. See, it's been a long time. Let me see the features and properties of stack. Does it allow a duplicate or not? You all also will be clear about that. How Java has implemented stack, because every API they will implement stack based on their way. So here how they have implemented. Let me check that. Hmm. The browser is a little slow. It's still loading. Duplicate values in set collection, not to remove duplicate from given stack, removing duplicates from the beginning. Why cassette can't see they are saying remove the pair of duplicate using stack. That continues. Does Java allow duplicates in Java dot util dot stack? A map cannot contain duplicate keys. Each key map must have value and cannot contain duplicate key. Stacks removing duplicate. This is not that. Let's do something like stack versus what is that? Vector. Yes. So we'll come to know. Why Naukri? Yeah. I don't want to get into Naukri. .com. Go to some other website. Hmm. So some more system is big. So vector is absolutely stack as a subclass. This vector. Uh, Boolean C to the stack class introduced. No, it is not given here. So what these are called data structures, right? Stack present with last in first out data structure. The last element added in the fast to move out. That is the rule of data structure, right? And that is the rule of stack data structure. Co-op can remove element peak. Similarly, they have peak. This method also is their queues, but there is nowhere it is mentioned about duplicate. Let's go to the stack class and see if it is mentioning. The class represents last in first out stack of object and it extends the vector with five operations that allow vector to be treated as a stack. The usually and operation are provided as well as method to at the top item on the stack. A method to test for whether the stack is and a method to the stack for an item and discover how far from the top. When the stack is first treated, it contains no item. A more complete set of LIFO operation is provided by the link DQ interface. Its implement this should be used in preference to this class. For example, this. Okay. Push item to pushed on the stack. Pushes items on top of the stack. This has exactly the same effect as add element. Remove the item of the stacks. Object stack without removing. Synchronized peak. Synchronized. Okay, fine. And it has not mentioned. I don't know why this guy is not allowing to, you know, have more time, same object. The same object it is not allowing us to push. That's how it is, right? Let me create one more set of employee object and see if that is getting added to that, right? Now let's see. If it prints three object and one is not there, that means it is not allowing duplicate. Where it is mentioned, I go through the document. No, there is some issue in my stack implementation, but this is how you implement stack, right? This is how you implement stack. You push the object and you get the output. Okay, so this is how you implement it. Employee ID 52 Satya Satya. Now it is showing only Satya Satya. That means it is only trying to push two elements, right? It is not pushing, it is not trying to push the more elements, and it is not trying to do pop out of more element. Let me do here less than equal to. Or maybe my pop is having wrong, you know. Yes, pop is having wrong. That means we should get four element here. See, so much of things we try, and you get Satya, Satya, Satya. So basically, we got, it's basically not taking duplicate. That's what it means. It is not taking duplicate, right? So let me add one more EMP here, and we'll see if we are seeing the four objects here. That means it is not taking duplicate. One more object added, right? EM triple P, EMPP, EMPP, four P's. Right? All are added now. Let's see. This is like this. By doing this example, it is not that we are going to get sure. Okay, it is adding all the four objects. But here, what I am trying to tell you here, stack implementation in such a stack is implemented in this way, and you need to be very careful how you are implementing stack, right? So this for loop I am using to pop it for four time because I've entered four. So rather having this size directly, I can say I is less than 4 because I'm starting for 0, 0, 1, 2, 3, 4, right? So let's see. So it is getting 4. That means there is some issue with that size, stack employee dot size. What it was, stack employee or something else? Yes, stack employee dot size method has some issue. Fine. So directly if I give 4, I'm getting it 4 times, right? So let me see EMP, EMP. So there is a issue with this size method. We'll see why it is an issue. See, it is popping out, right? How many times? Four times. Duplicate is allowed. That's what I know. Duplicate is allowed. I was just a bit confused. So let's see what this size is giving us. This size. We'll print this size here. Stack employee dot size. Right at the end. So let's see what it is trying to print. It should print 4. It should print size should get print 4. Oh, it's giving us 0. See, it is giving us 0 because for for stack there will be no index. It will be like push and pop operation. That's what I said. So we might have some methods there, but it will not work as it is. Anyway, so this is what our array list and collections array list in collection, but the list interface and its implementation on collection interface. We will go for the set now, and we'll finish set today. Good. Let's keep the same employee object with us. So here we'll create when set, a method for the set. What is set? Set is always store the Unix, right? It is same as list, but it stores Unix value, unique value, and ordered when set. So let's go with as set first. So I will show it the non-primitive, then we'll go with primitive, and then the generic. No generic, right? You know what is the use of generic? That E, right? How to use E, how to use T? I will tell you in when I'm talking about generic, especially one session before generic. I'll show you some example with E and T. See, has set now. I created. So I'm going to store here some integer has set dot add, right? So you can use the same for loop or method, right? What we have done for the array list. So let me take this guy, right? Right? Now it is file storing. It is for printing, right? So now has set dot add, and then what is that has set See, if you see the methods availability, you will find most of the method is present in there. Uh, you know, uh, Most of the methods are present in both the list and your visual classes, right? Most of the methods are present. Let me upon this, you know, set collection in Java. Let me upon that thing. So then we'll go with the. See, always you can refer Oracle document also. It is Java 8, so you can refer the latest document. Just go for one of the website. I will upon you about Java set before explaining that. Allah you will do this thing. Set interface. See, here you have set enum set, hash set, link set, tree set. So we started with hash set, right? Sorted and navigable set. Extend sorted set and navigable set. Right? See, this is total what Java interface. Java set interface that Java collection framework provides the feature of the mathematical set in Java. It extends collection. That's what yesterday I said, right? Since set is an interface, we cannot create object from it. In order to functionality the interface, we can use these classes: asset, link asset, enum asset, tree asset. Right? This is how they are saying. They are using generic also. See, string, animals, asset. I will use also that add all, iterator, right? And then remove all iterator, returns an iterator that can be used to access element of the set sequence. Remove all, return all, clear, size, these are the basic methods what they have given here. Some of the commonly used methods collection interface that. So you see you have add and add all methods, but you don't have retrieval. How you are going to retrieve from a hash set? You don't have that method. You can if you want to retrieve, how you are going to retrieve? You don't have that methods. So for retrieving, you have to use iterator, and then you have to do iterator.next. That is what here it is. That's why I was showing you here. Here, that's why you see add and add on. That's the example he has also given, right? So here, if and this guy is not going to work, here we have to use iterator. So that's what I was thinking. Why, you know, this method is like this? Why all are there? See, this iterator is like this. So we have to use hash set, not en. En, I don't have from where it came. Hash dot dot iterator. You use this right, dot hash next. Something will be there. And then hash next will return true or false. If the item is there, it will return true. If the item is not there, it will return false. So then here it is. What we will do? Hash set dot iterator dot next. Right? We will do this. And we will run it. It is printing 0 0 0 0 0 0 0 0 0 0 0 0 0. Okay. So something might have gone wrong while implementing this. Why it is printing only zeros? We already added this, right? So see, something might be same only implementation. Iterator dot has next, right? Numbers iterator has next. Same thing, iterator dot next. That's what I got confused. Hmm. Maybe you notice. Let's do this. Might be creating another reference on new iterator object each and every time. You know, that might be creating trouble. and here it is it.next. Yes. So it was each time, no, it was initializing the iterator as nest and it is trying to check. So and when each time it is only going to the fast index. I it's been a long time, so that's fine. Currently, I am no more, into development. Though I am an engineering manager, worked as an engineering manager or engineering leader, not that much into coding. So sometimes it happens, right? The core thing is you people should learn the concept. This video is for you, and you all should learn the concept how set works. Set you cannot access through index. It is always sorted way. Then the way you have inserted, it will go in that particular fashion, right? That's what it is written in for. Here also, that is what it is mentioning for hash set, right? Okay, it is implementation. Yeah. So I will show you one more example, right? A tree set. Linked hash set will be the same way, enum set is same. I will show you one more tree set. Here I will do one more thing here. One more thing I will say show you add on method, right? What happened? Multiple marker at this time hash set is a raw type reference or generic type hash set should be permitted. Hash cannot be result to a type. Why? Why? Okay, small s. Now let me add for this hash set. You know, starting from 11 to 20, right? I added in the second hash set. What I will do hash set dot add all, and I'll pass the second one. Now let me paint it. See, you got till 20, it added everything to the hash set, right? Now let's go for one more method, tree set. Or here, what I will do, I'll just make a tree set for you. Right? These all are in video. You can always pause and see what I've done. Tree set. No generic, right? Generic. You know what is the use of generic. See, it added. So I created a tree set, and in this tree set, I inserted first was 0 to 10, and then I created a hash set and inserted 11 to 20. And inside the tree set, I added the hash set. And see, it is you're able to see all 20 elements here. Fine. So see, one more thing I'll tell. I'll just comment it out. I'll just comment it out. Or this, till add-on. Now I'll do this tree set, right? So tree set dot add. I will add something here. Let's say 8. 6. Three, 10, 11. Right? So I added these all. elements here. These many elements, right? Now let me run it. See, 3, 4, 6, 8, 10, 11. What happened? It got sorted, right? How it was added? 8, 6, 4, 3, 10, 11. So tree set is sorting it according to natural order. If you all might have read data structure tree is the following the concept of binary tree, sorting it into the what? Natural order, the way it is created, right? Now what I will do, I will make it hash set. See what will happen. Okay, this I'm going to make it hash set. I made it hash set. Now see in case of hash set what happens. See 3, 4, 6, 8, 9, 10. In case of hash set also, it is maintaining the natural sorted order, right? If I make it linked list, linked hash set. In case of linked hash set, right? You know, if a person is trainer, he will go fast and he will explain you fast. So I'm not a trainer, and that's why I'm going slowly with all practical implementation. See what happened in linked has said. In linked has said it is going in the insertion order because it follow the linked list concept, right? 8, then 6, then 4, then 3, then 10, then 11, right? Now if I do come back to has said, tell me how it is in has said. This is the output which you are seeing from the linked has said. Now it is normal has said. 2, 3, 4, 6, 8. Natural order. Tree set and has set goes with the natural order. So now in this place, what we will do? We will insert employee, right? We will insert employee. I'll just copy employee object from here. You know, when I release one object and then I will go with the other. Yeah, before going to that, I want to show you something. I will insert one more 8 in asset. The duplicate thing, right? See, only single 8 is there, no duplicate is inserted. That same concept goes to all the set implementations. So see, like this, you can read from the book and you can practice. No duplicate entry, right? Check for the link as also. This is very easy, you know, programming language. If you want to learn, you can sit at home without, and if you're not that curious, that interest, you can always experiment to this. That's what I did in my school. All basic programming language to become more stronger in computer programming language. That's how I did in my school days, and that's how I have learned and grown. See, there is no duplicate. There is no duplicate element here in hash set, right? There is no duplicate 8 inserted in the linked hash set or hash set or tree hash set or the enum set. So nowhere it is. Set is not allowed duplicate. This is how I have practiced. You know, when I was reading my high school time. I am from ICSC, and that time we had basic, beginner, all proper symbolic instruction code programming language, basic programming language. You know, I love that language. I have created lots of things in that language. It was very good. We also created a project at a time, employee database, employee age, employee salary, everything. It's like a payroll kind of database. So now we'll go with the employee. Let me copy it again. In employee also, I will show you duplicate is not allowed. That time this equals method and other method will come into picture. Then that linked asset should be there, and we will start from there. We'll insert two, three. Created four, huh? First one, let's say EMP, and we'll add it here. Dot add EMP, right? The same, we'll add it here. The same, we will add it here. The same, we will add it here. So here one EMP is added, right? Here another EMP is added. Let me remove this. Here another EMP is added, right? And all are 81, 81, 81. All IDs are 81. Now let me remove this one. Sorry. Let me remove this. Right? Let me remove all this. Whatever we had till the iterator. Let's clean it. So now I'm running it. See what happens. All are linked asset. Huh? We have only one object. No duplicate allowed. Right? Now I'll make it because I'll tell you why. Wait, hold on. Now I'll make it 2, 82, 83, and then I'll make it 84. F4, right? Now you see. All are visible. You know why? See, this employee class we have written what? Equals to method. We already implemented the equals method and we have overridden the hash code method. Right? We have implemented equals method and we are overridden the hash code method. And this equal method, what we are checking based on the ID. If IDs are same, then that object is duplicate. So that's how the set is able to identify the object is duplicate, is not able to insert all four. Now let's say I'll make it one. I made line number 16 ID is your what is that 81, line number 24 ID is 81, line number 32 ID is 83, line number this ID is 8440. See all these employee IDs have changed, right? And I will make one more here, 81, right? 40, I made 81. Let me run it as Java application. See only two, right? Only two, which one is represented? The first one and the what? First one it is printed and the which one? One is printed with 81 and the other is printed with 83. So that's how. So here duplicate is already identified, right? It identifies duplicate. I made another 82, line number 16. Now let me run it. You will see one more object will be displayed, right? Now let me make 82. Line number 32, I made 82. See 2 it is because 81, 82, 81, 82, right? So that's how. Let it be 83, line number 16, and let it be 24, let 24 be 83, and let 16 be 82, and let 32 be 84, right? and 40, 81. So now see, all of them will be represented properly, all objects. See, now what I will do, I am just doing iterator.next. I will do get. See, if I am doing this, it is not showing me what to print. So what we have to do, this is returning an object type. Here, we have to downcast it to employee. Right? We have to downcast it to employee to print. So this is where I can downcast in one single line. Otherwise, I can downcast, using some other line. After that, I will show you how easily it is in generic. You not equal to downcast. Let me run it now. I'm just printing IDs, right? See 82, 83, 84, 81. You got it? The object IDs, right? Now let me go to line number 40. Line number 432, make it 81 to show you that what we did that was actually right. Now it will print only 3, right? You got it? So now using generic. So let's say this. Okay, before going to generic, let me show you one more thing by making this as tree set. What happens? Linked has set, how it go. It goes with the insertion type always. Insertion order 82, 83, then insertion is 84, then insertion is 81. Right? So let me run it. You will again, so that the sequence will be there, then we will change it. The way we insert linked hash set that works in that way. See 82, 83, 84, 81. 82 ID, then 83 ID, then 84 ID, then 81 ID. The way we inserted it got printed that way, right? So let me go to reset. Class cast exception. Employee cannot be cast to line dot comparable. Employee is unable to comparable in the model of Java loader bootstrap. Where is that mean? Java loader bootstrap. Tree map 1607, tree map, then set 21. Where it is? Line number 21. What it is? Class cast exception. Class file dot assume data frame cannot be cast to Java dot line dot comparable. What is this? Hmm. Let me use, you know, generic here and then we'll see what it is saying in that cache exception. There may be something wrong with the equals method or somewhere. Let's see. Comparable is telling. Equals method, why comparison will fail? Yes. Yeah, it's the same thing. Loader up model loader Java class loader bootstrap loader Java class cache to comparable tree map Java. The first exception comes from the tree map Java 1607 line number. What is that 160 line number 7 line number? Comparator null, comparable super K, compare to K2, comparator compare. Compares to key using the correct comparison method for this tree map. Why it is going to tree map, man? We are using tree set, right? Yes. Hmm. Internally, internally, it uses. You know, internally, while adding this element into the tree set, it internally uses map to sort this parameter. That's how it is. Employ, but why? Why it is throwing like this? Add employee to T bullet reset, right? Okay, hold on a little bit. About to employee class. Yeah, I'll just comment this. Then this equal method and mascot method. Everything will come. This should not create any issue. Equals method and this Haskell method, this should not create any issue because the return type, whatever Java is expecting, we're returning the same type. So it should not be an issue at the any moment of given time. Yeah, that's what I said. No? It is nothing to do with that. It is nothing to do with that equals and Haskell method because we have followed the contract of equals method and Haskell method, we implemented it. So let's go to the main set and let's see what happens with hash set. Then we'll go to tree set. Okay. It was working properly with linked hash set. Now we're trying hash set. See, it is working with hash set. So in hash set, what happened? It followed the ascending order of numerical values, right? Ascending order of the numerical values. So that's how it is. It doesn't matter insertion, but in linked asset and asset, linked asset, it will follow the insertion. In linked asset, it will follow the insertion order, and whereas in asset, it will follow the natural ordering of that particular data type or type of values. It is since it is numeric value integer, it will follow ascending order of that numeric value or integer. So tree set. Tree set is not working. Why not working? We have to check that now. We'll check it. Tree set. Right? And again tree. We have set tree set for employee. And here what I will do, iterator. Iterator was, yeah, I thought I told you how to make this iterator also like employee. Right? So now this guy is not required. Directly you can make it. See, now this has reset is giving error. I will show you with has set and then we'll go to reset. Right, I've done this. Let me run it now. So down casting is not required anymore if you use generic. That is the advantage of generic in case of iterator, right? So this is how it is. Now reset. Reset. We have to see why this guy is not working. Why reset is not working properly. Thread main Java lang class exception count dot example cannot be cast to comparable. Why? Okay, fine. So let's say there is one, I think they were expecting us to implement comparable. I will talk about comparable and comparator. Okay, comparable. Right? This is what he's saying, not. So let me go with this comparable and let me run it. Is it forcing me to implement or override the compare to method? We'll check it. That is not required actually. Default compare to method should take care the way it has taken care for the set. Yeah. Inherited abstract method comparable. That's what I told you. You have to inherit. If you're inheriting it, you have to override it. See, it's not required because you have implemented when it is required. In case of map, it is required, but in case of this, it is not required. Anyway, we'll implement it. Right? So we'll implement it comparable. What we will do, we'll take from here this get ID thing will take from here and add it to here. Right? employ. What is this, buddy? Why is this equal to this ends here? This equal to ends there. Yeah. Change method to return type of boolean. Oh, okay. Now it is 0. Sorry, this is 1. And this is 0. Right? So let's go and run our. I'll explain this, don't worry. If not possible this session, I'll explain it in the comment section because almost it's going to be 1 hour. Yeah. So it gave what it started printing only 82, right? Only one. Do we have duplicates here? 82, 83, 84, 81, not duplicate, but it started kept printing as only one after implementing the comparable. The comparable may not be implemented in a right way, so that's the reason it has given that. Just I change the value, I will explain what this method does in this session and I will implement it properly and tell you why this tree set created that kind of problem. See, actually I did a mistake. I did a wrong value set. So now you got all of them, right? 82, 83, 84, 81. Yeah. So don't worry about this. Why it is like that? I'll explain you in detail. But before that, today, before ending the session, I'll go to compare to and I will explain what is this. See, in case of collection, there are two classes are there, comparable and comparator, right? When we are comparing, you know, when we are comparing with non-primitive data type, when we are comparing with primitive data type, what actually happens? When we're comparing with primitive data type, primitive data types always have a natural order. Primitive data type always have natural order. Since these primitive data type they have natural order, what happens? They go with the natural order. And if we don't want to go there with the natural order, we want to define something with our own way of sorting or our own way of sorting these objects, then we need to go with our own sorting algorithm, right? So when we want to go with our own sorting algorithm, then we need to go with comparable or comparator. If you implement comparable, if you want to implement comparable, or if you want to go with your own sorting algorithm for employee, see here only I have written one sorting algorithm sorted based on something compared to based on the ID. That is what I have mentioned here, right? And if you see the output, it is here, right? So see, this is not right implementation. I will give you the right implementation and I will tell you what is the contract given by compared to methods of comparable class and compare method of comparator class, right? Similarly, comparator also is a class which is used for sorting collections, and there we have to implement the compare method, right? So here I will show you the contract and how to implement compare to. The comparable method and comparator method are used for sorting purpose or for checking similarity of objects. That is a non-primitive way. Or if you want to define your own algorithm to check it, right? So it is comparable. I will show you one more class. Hold on. Um, comparator. Another. Yes. So, see, comparable has compared to method. It is an interface which has compared to method. We have to override this method and give a definition to this method so that it will be used in our collection classes. We're comparing our own type of comparison. See here we have in comparator we have compare method. Here you have to pass both the object whom you want to compare. There are only one object because this object will be taken care, right? Using the other object. It has few other methods like reverse and all other, but if you see compare method is not implemented, we have to override the compare method. Here also you have a contract to follow when implementing compare method. See, the thing here is when you're using comparable method, your class will extend the comparable method, right? Your class will extend the comparable method where you want to apply the sorting algorithm. That is, in this case, we want to apply the sorting algorithm in case of uh, employee. So employee will implement comparable method, and you will have only one type of sorting in this compared to method. Or maybe by having if else condition, you can have multiple sorting. But if you use comparator class, if you use comparator class, you can have multiple comparator class with multiple sorting algorithm. Wherever which one you want, you can use that comparator class to sort your non-primitive data type or object like employee, right? So this is how we coming session we will see this map and this comparable and comparator. So this is a critical path of your or a it has little complexities. Try to understand this. This is how it is. Anyway, if you are watching my videos and if you see any opportunity anywhere as senior engineering manager or engineering manager or similar kind of position or higher, kindly let me know. Let me know so that I can apply for that position. It's been long time. I don't have any job. I am sitting idle, and this idle time I'm trying to utilize my learning experience with small programs one after the other. And what I will do now, people are nowadays going for full stack development. So once I complete this thread chapter, after that I will slowly, give you a full stack development of Java. How you can do create a whole project with Java. After this, I will try to show you how to integrate with other databases, then how to create REST API, and then front end. This whole thing in this session we will have. If you are seriously watching, watch it. Thank you. Thank you, everyone. Today we'll end this session here. And in coming session, watch uh, what I'm going to discuss is comparator, comparable, and map. So stay alert, watch, keep learning, keep growing. Thank you, everyone.